everyone, thank you so much for clicking onto the video. Today we're going to be looking at the chlorination of alkanes. So we're going to look at the reaction of methane with chlorine, and by the end we should be able to explain this reaction as a free radical substitution mechanism involving initiation, propagation and termination steps. Now we're going to talk about the chlorination of alkanes. So in the presence of UV light, alkanes react with chlorine to form a mixture of products with the halogens substituting hydrogen atoms, and so we form a halogenoalkane or a haloalkane. So the definition of a haloalkane is a group of chemical compounds derived from alkanes containing one or more halogens. So in this example, we'll be looking at CH3Cl, which is chloromethane. And the really important thing to remember about this is that it is a free radical substitution reaction. And so our example is methane reacting with chlorine. So this forms chloromethane and also hydrochloric acid. So we need to remember our 3 steps of free radical substitution reactions. So in the first step, the chlorine bond breaks, and we have to remember that it's in the presence of sunlight. That's really important. And this forms our chlorine free radicals. And also remember that for initiation, breaking the Cl-Cl bond, we can break it homolytically or heterolytically, where heterolytically means that one of the chlorines gets both of the electrons of the bond, so that ions are formed, whereas homolytically means that they both get their electrons back, and so 2 free radicals are formed. So in this case, in initiation from free radical substitution, homolytic fission happens of the covalent bond. And now on to the second step, we have propagation. And propagation has 2 steps. So the first step is that the chlorine free radical reacts with methane, and this forms hydrochloric acid and also a CH3 free radical. And this CH3 free radical then reacts with more chlorine to form chloromethane and also a chlorine free radical. And so because we form a chlorine free radical, this is the chain part of this chain reaction. And the last step is when free radicals react with each other and are removed from the reaction mixture. So now we're going to have a look at this reaction. So the first step is initiation. So number 1 is initiation, and what happens is that this chlorine bond, this covalent bond, breaks homolytically. So we've got Cl, Cl, and that's the covalent bond that I've drawn. And this, under the presence of sunlight, so we write UV, forms 2 of these free radicals, which we denote by Cl dot. And these are really, really reactive. And so these are what are used in propagation to form the chloromethane. And so the second step is propagation. And what happens first in the first step is that a chlorine free radical will react with the methane that we have, and this will form it'll take away, the free radical will take away one of the hydrogens from the methane. So we'll form hydrochloric acid. And then that means that the methane will be left with one less hydrogen, so that itself is a free radical. And we always put the dot where the atom is missing. So the hydrogen is missing from the carbon, so we put the dot on the carbon. And the second step is where we have this CH3 free radical reacting with chlorine, and this will form our chloromethane, so CH3Cl, because basically it takes one of the chlorine atoms from the chlorine. And so we get a chlorine free radical. And so this is the free radical that goes and then repeats these 2 steps. So this is the chain reaction. And then thirdly, we have the termination step. And what happens here is that two free radicals then react together and remove themselves from the reaction mixture. So we can do this in a couple of ways. So we can have two chlorine free radicals reacting to form chlorine, or we could have a CH3 free radical and a chlorine free radical reacting to form some more of this chloromethane, or we could also have two of these CH3 free radicals reacting to form CH3CH3. And so these are three steps for this reaction. So then overall, what we have is that we started off with some Cl2. So we've got some chlorine, and we reacted it with this methane here. And then what we produced was we produced this hydrochloric acid, and we also produced this chloromethane. And that's because if you have a look at this free radical, we've formed it in the first equation, but we've used it up in the second equation. So this is what we would call an intermediate. So it's not included in into the actual reaction. Now we're going to look at some questions. So for question 1, dichloromethane is one of the products formed when chloromethane reacts with chlorine. For A, name the type of mechanism involved in this reaction and write an equation for each of the steps. So we can see that what's happened is that we've substituted a hydrogen for a chlorine, and so this must be a free radical substitution. And now write an equation for each of the steps. So the first step is the initiation, and this is where we actually form the free radicals. So we start off with chlorine, and then we have to add UV light, so that's really important, and then we form two of these chlorine free radicals. And then we have the two propagation steps. So in the first step, we have a chlorine free radical reacting with the chloromethane, and this will form, and so the chlorine free radical will take away one of the hydrogens, and so we form CH2Cl, where that will be a free radical, so the carbon has lost the hydrogen, and HCl will also be formed. And then in the second step, we have the new free radical that we've formed, and that will react with more chlorine to form this dichloromethane that we were after, and also a chlorine free radical. And so this chlorine free radical then goes on to repeat these two steps again and again, and so this is the chain part of the chain reaction. And then the last step is termination. So this is where we react two free radicals together to remove them from the reaction mixture. So we can either add two chlorine free radicals together to form chlorine, or we can react together a chlorine free radical and this CH2Cl free radical, and that will also form, and this will also form this dichloromethane, or we can react these two CH2Cl free radicals together, and this will form Cl, CH2, CH2Cl. And so these are our three steps. For B, write an overall equation for the formation of dichloromethane from chloromethane. Okay, so we basically just combine all of these equations together, just the propagation ones. So we start off with this chlorine. So we have chlorine, and we add it to this chloromethane, so CH3Cl, and this goes to form this dichloromethane and also hydrochloric acid. And this is because this free radical that's formed is an intermediate, and because it's produced in the first step and used up in the second step. And this Cl free radical we call catalyst because it's regenerated at the end. And then for C, a compound contains 10.1% of carbon and 89.9% of chlorine by mass. Calculate the molecular formula of this compound, given that its relative molecular mass is 237. So we've got carbon is 10.1%, and we've got that chlorine is 89.9%, and the MR of the compound is equal to 237. And so what we do first is we have to work out the molar ratio of carbon and chlorine. And so to work out moles from the percentages is that we need to divide by the AR, so the relative atomic mass. So we have that the moles of carbon is equal to 10.1 divided by 12, and this gives us 0.842. And then we work out the moles of chlorine, and this is equal to 89.9 divided by 35.5, which is the relative atomic mass of chlorine, and this gives us 2.53. And so the molar ratio between carbon and chlorine is equal to 0.842 to 2.53. And now what we can do is divide them both by this 0.842. So we get the ratio 1 to something else. So they're easier numbers to look at. So we can do 0.842 divided by 0.842 to 2.53 divided by 0.842. And this gives us a ratio of 1 to 3. And so we get an empirical formula of CCl3. And then what we do now is we take the MR of the compound, so we know that MR is equal to 273, and what we need to do is divide this by the MR of CCl3. So 273 divided by the MR of CCl3, which is 12 plus 35.5 times by 3, and this gives us 2. And therefore, the molecular formula is equal to C2Cl6 because we times everything, we times all the quantities in the empirical formula by the factor that we've just found now, which is 2.